Today we're going to talk about graphing absolute value functions. So first let's get started with what we need to be able to do. So our success criteria today, we have to be able to graph absolute value functions. We need to be able to find the domain and range of absolute value functions. And we need to be able to describe transformations of graphs of absolute value functions. So graph, find the domain and range, and describe transformations. Definitions that we need to know today: an absolute value function is a function that contains an absolute value expression. The vertex is the point where the graph changes direction. And vertex form of an absolute value function is written in the form g of x equals a times the absolute value of x minus h plus k, where a is not equal to 0. The vertex of the graph is hk. So if it's written in this form, your vertex is hk, and that's where the graph changes direction. All right, so these are the definitions, a little bit more detailed, a little bit more information here. Also talks about the domain and range, which we will be looking for. All right, so f of x equals absolute value of x. This is your parent function. And you can see the turning point here where it changes directions. That is your vertex. Vertex form again. G of x equals a times the absolute value of x minus h plus k, where a is not equal to 0. And the vertex, when in this form, is hk. Any absolute value function can be written in vertex form, and its graph is symmetric about the line x equals h. So your horizontal movement here, that is where your graph will be symmetric. Okay, let's look at a few examples. All right, translating graphs of absolute value functions. Graphing g of x equals absolute value of x plus k, and g of x equals absolute value of x minus h. Graph each function, compare each graph to the graph of f of x equals absolute value of x, find the domain and range. All right, so you can see that g of x equals absolute value of x plus 3. So if you know that the absolute value of x is a v-shaped graph at the origin, hopefully you will see that plus k, this is going to be a vertical movement up 3. If you want to make a quick table just to see how that works, you can, let's come up here. Let's do x and g of x. All right, and remember we want a v-shaped graph, so you don't want to start at 0 or you're just going to get half of that v. So you need to have some negative and some positive values. So let's just choose -2, -1, 0, 1, 2. All right, so if I plug in -2, absolute value of -2 becomes 2. 2 plus 3 is 5. Plug in -1, absolute value of -1 is 1. 1 plus 3 is 4. Plug in 0. 0 plus 3 is 3. Plug in a 1. 1 plus 3 is 4. And substitute 2, or plug in 2. 2 plus 3 is 5. All right, so you can quickly make a table of values by choosing x. Remember, x is your independent variable, so you can choose x's. Just make sure you choose some negative and some positive so you get an actual v. You don't want to get a straight line because you only choose points on one side of the vertex. All right, so if we go -2, 5, -2, 1, 2, 3, 4, 5, -1, 4, 0, 3, 1, 4, and 2, 5. All right, now I can make my v-shaped graph. And that would be the graph of absolute value of x plus 3. You can see that it is the same as the parent function, shifted up 3. So k is just a vertical movement of the whole entire graph. All right, your domain is all real numbers. We can write that as negative infinity to infinity. Our range is our y values. Our y values go up and down. You can see that it starts at 3 and it's everything above 3. So we can write that as y greater than or equal to 3. All right, for B part, m of x equals absolute value of x minus 2. I know that this is a horizontal movement to the right 2. So I know my vertex is going to be at 2. So if I want to make a table of values, I need to pick values from like 0 to 4. So let's look at this function. So x and m of x. So 0, 1, 2, 3, 4. All right, if I plug 0 in, 0 minus 2, negative 2, absolute value of negative 2 is 2. Take 1, 1 minus 2, negative 1, absolute value of negative 1 is 1. 2 minus 2 is 0. 3 minus 2 is 1, absolute value of 1 is 1. 4 minus 2 is 2, absolute value of 2 is 2. All right, so take these points and plug them in. So you got 0, 2, and I've got 1, 1. I've got over 2 and 0. And I've got 3, 1. And I've got 4, 2. So again, you can see that this is the same V-shaped graph. It's just been shifted 2 units to the right. All right. I didn't hit my points very well, but let's look at the domain and range. So again, it goes left and right with arrows, meaning it's going in both directions forever. So again, that's going to be all real numbers, which can be written as negative infinity to infinity. And your range is your y values. You can see that 0 is included, and the arrows go up, so it's going to be everything greater than or equal to 0. All right, going to move on to the next example, graphing g of x equals a times absolute value of x. Graph each function, compare each graph to the graph of f of x equals absolute value of x. Remember, that is your parent absolute value function. Find the domain and range. All right, let's start by making a table of values. So it says q of x equals 2 times the absolute value of x. So let's say we've got x's, and we're going to have q of x. All right, we know that the absolute value starts at 0, so let's pick a couple numbers on both sides of 0, because we're going to multiply it by 2. But again, to get that V-shaped graph, we have to have numbers on both sides of the vertex. All right, so negative 2, absolute value of negative 2 is 2. 2 times 2 is 4. All right, same thing, plug in negative 1. Absolute value of negative 1 is 1. 2 times 1 is 2. Plug in 0. 0 times 2. Plug in 1. 1 times 2. And plug in 2. 2 times 2 is 4. All right, once you quickly make a table of values, you can graph these as ordered pairs. This is your x, this is your y value. So negative 2, 4. Negative 2, 1, 2, 3, 4. Negative 1, 2. 0, 0. 1, 2. And 2, 4. All right, let's see if I can draw a V-shaped graph here on the computer. You can tell my lines are not very straight. My hand is just not that sturdy. Let's try that one again. All right. I do much better on paper or on the board. All right, so let's look at the domain. Pretend like that is a nice, smooth V-shaped graph. We are looking for the domain of this graph. The domain goes from left to right. It's got arrows going in both directions, left and right, so it's all reals, or negative infinity to infinity. And the range would be everything that is above 0. So you can see the y values here. The vertex is at 0, 0, and the arrows go up. So this includes everything greater than 0. So y greater than or equal to 0. Remember, your x is your domain, your y's are your range. All right, so here, B part says P of x equals negative 1/2 times absolute value of x. So again, let's generate a table of values. So we're going to have x. We're going to have P of x, which is the same as your y values. Since we're having a multiplier of x, we can still just use numbers on each side of 0 to find that vertex. All right, take negative 2, substitute negative 2 in, you get 2. Half of 2 is 1, and so it'd be negative 1 here. And then we'll take negative 1 and plug that in, it becomes 1. 1 times negative 1/2 is negative 1/2. 0 times anything is 0. 1 times negative 1/2 is negative 1/2. And absolute value of 2 is 2. Negative 1/2 of 2 is negative 1. All right, this does say negative 1/2 here. All right, so let's graph the ordered pairs again. Negative 2, negative 1. Negative 2, negative 1. And this should make sense because where this is a negative number, remember that's a reflection across the x-axis. So we are reflecting across the x-axis. So now our v-shape is going to be upside down. All right, so negative 1 and negative 1/2. 0, 0. 1 and negative 1/2. And 2 and negative 1. And if you want your V to get larger, all you have to do is pick more points to the left and to the right of the vertex, and you would have more points to graph that V-shaped graph. I'm going to try to graph it right here. Let's see. Again, I'm trying to draw straight lines. This should look like a V-shaped graph. I probably should use the lines that they give me. Let's see if I can use the lines they give me and do a little bit better. All right, I lost my points here. Negative 2, negative 1. All right, let's see if I use this, if I can do any better. All right, so let's see. Let's go here. Oh, yeah, that looks better already. All right, so let's go here. And now let's draw a second line. There we go. That looks much better. All right, the domain, again, goes left and right in both directions forever, so it's all real numbers. So we're going to say that is negative infinity to infinity. And our range, this time it goes down. So it includes 0, but it goes down to the negative. So it's going to be y less than or equal to 0. All right. All right, one last touch. I did go back to A part and use my lines here to make that V shape look a little nicer. So we will move on to the next examples in the next video.